All right, let's go ahead and go through this problem together. Here's how this one starts. Suppose you just received a shipment of 13 televisions. 4 of them are defective, and you are selecting 2 TVs. So this problem is asking us first off to find the probability that both TVs work, and then next to find the probability that at least one of the 2 televisions does not work. All right, so let's go ahead and get started. For the first problem, I have 2 events. First off, I'm selecting the first TV, and then I'm also selecting the second TV. All right, pardon my bad handwriting, I'm trying. All right, so first off, before we select any TVs, let's go ahead and talk about what we have here. Well, first off, I want 2 televisions that work. So my first probability is I've got 13 televisions total, and out of the 13, well, if 4 of them are defective, that means that I have 9 TVs that work. So that is my first probability there, is that I have a 9 out of 13 chance in order to get a TV that works. All right, now let's go ahead and talk about our second TV that we pick. Now, looking at this probability, it has now changed. First off, instead of 13 TVs to select, I've only got 12 to choose. And I did have 9 working TVs, but I just selected one. So if I had 9, now I'm down to 8. So these are the 2 probabilities that we are multiplying together. So our first event, before we had selected anything, I had a 9 out of 13 chance of getting a TV that works. And then for my second one, I had an 8 out of 12 chance. So if I were to multiply these together, 9 out of 13 times 8 out of 12, I'm right at about a 46% chance. So this answer would be, let me go ahead and zoom in a little bit, 0.461, 0.461. That would be 0.461. All right, so that is for the first problem. Now, here we go. For the next problem, I want to know, find the probability that at least one of the 2 does not work. Find the probability that one of the 2 does not work. Well, let's take a look at all of our different possibilities here. Hopefully we can find a little bit quicker of a way to do this. So here are our options. First off, we could figure out, hey, we could have a working one and another one that works. We could have a broken one first and then one that works. We could have one that works and then we could have a broken one, or we could have a broken one and another broken one. Those are all of our 4 possibilities. So either first one works, second one works, first one's broken, second one works, first one works, second one's broken, or they're both broken. Now, it is asking find the probability that at least one of them doesn't work. So one thing we could do is we could repeat this whole process for all of these. But that seems kind of silly to repeat this process and add this probability plus this probability plus this probability. I know that all of these have to add up to 100%, correct? So if I want to know, find the probability that at least one doesn't work, well, if the probability that they both work is right at 46%, if I know that the probability of this is right at 46%, well, hey-o, if this all adds up to 100%, I can figure out this one by just taking 100% minus 0.461. So for this answer, here's what I've got. I could add up all of those and calculate it just like I did up here, or, hey, the probability that they both work is 46%. Well, that means the probability that one of them is broken is going to be 1 minus 0.46. 1. And then finally, if I do that, 1 minus that, 1 minus 0.461, that's right around 53.9%. So that is our answer there, 53.9. Now heads up, it does look like I did rounds incorrectly. I am so sorry about that. That should be 462. I don't want you to get that one wrong. So that's 0.538. So let me go ahead and write those out. This should be a 2 here. 0.538. And then going back, I am so sorry that I rounded wrong on that one. That should be a 0.46. All right, hopefully that cleared up some things. As soon as you had the first part, you could repeat this process down here 3 different times, but really I would say just it's easier to do 100% minus the probability they both work, And then that's the probability that we got a TV that doesn't work. All right, let me know if you need any more questions.